these notes are all about Newton's third law. So your learning targets are, I can describe Newton's third law, and I can define momentum and explain the conservation of momentum. What is Newton's third law? Newton's third law is also called the law of momentum, and it states that for every action, there is an equal and opposite reaction. So remember back from our force notes that forces come in pairs. One is the action, and the second is the equal and opposite reaction. So if object 1 causes a force on object 2, then object 2 causes an equal and opposite force on object 1. Let's take a look at a couple of examples. Example 1, if you hit a wall with 100 newtons of force, how much force is exerted on you? So again, if we're going to go through and we're going to explain this, we have some key terms. Okay, we have, first of all, the action force. So what is the action that's occurring here? Right? We have a person pushing on the wall. What is the reaction force? The reaction is the wall pushing on the person. So again, remember that forces come in pairs. So we have two forces here. So the person pushing on the wall and the wall pushing on the person combine to make the force pair. Also, recognize that these two forces are equal. Because remember that the law states for every action there's an equal and opposite reaction. So, in the question, if you hit a wall with 100 newtons of force, how much force is exerted back on you? So the answer would be 100 newtons because it needs to be equal. Let's take a look at another example. So a bowling ball crashing into bowling pins. What is the action force? What's happening? The ball hitting the pins. What is the reaction force? Now this might be a little tricky. Remember that forces need to be equal and opposite. So what's the reaction? And the answer is the pins hitting the ball. The reaction is not the pins flying, even though that's what happens. Remember, equal and opposite. So if something hits something, it is also being hit back by that object. So how about the question, which one is stronger? Is the ball hitting the pin stronger, or is the pins hitting the ball stronger? And the answer to that question is neither. They are equal. Because remember, for every action, there's an equal and opposite reaction. Let's take a look at another one. Example number 3, a volleyball player bumping the volleyball. So it doesn't matter which force you list as the action and which you list as the reaction, as long as you can correctly identify the two forces in each pair. So here, what do we want to call our action force? The ball hitting the player's wrists. What do we want to call the reaction? The player's wrists hitting the ball. So again, remember that they need to be opposite. So the ball hitting the player and the player hitting the ball. And how about which one is stronger? Again, trick question. Neither is stronger. Remember that they are equal. And example number 4, why can't you hit a feather in midair with a force of 200 newtons? So remember that forces come in pairs. And these pairs are equal and opposite. So if you want to hit a feather with a 200 newtons of force, the feather must be able to hit you with the same amount of force. So can a feather in midair exert 200 newtons of force back on you? No. That's why you cannot hit a feather with 200 newtons of force, because it cannot give you 200 of newtons of force back. So a feather in mid-air cannot hit you with 200 newtons of force. So because forces need to be equal and opposite, you cannot hit it with a force of 200 newtons. Let's take a closer look at what is momentum. Momentum is the inertia in number form, and this is because we can calculate it. So the conservation of momentum states that momentum cannot be created or destroyed. Instead, momentum is transferred from one object to another. So here we're going to remember that more mass equals more momentum, and more speed equals more momentum. So how do you calculate Newton's third law? Momentum is equal to mass times velocity. Mass, which is symbolized by a lowercase letter m, has the units kilograms. Velocity, which is shown with a lowercase letter v, has the unit meters per second. And momentum, which is represented by the letter p, has the unit kilogram meter per second. There are different variations of this equation as well, so P equals mv, m equals P divided by v, and v equals P divided by m. Let's take a look at a couple examples. So example number 1, what is the momentum of a 50-kilogram dolphin swimming at 16.4 meters per second? So first, identify that information. So we have 50 kg. Kg is the unit for mass. And 16.4 m/s. So what is m/s the unit for? Velocity. So what are we trying to find? It says what is the momentum. So remember that our equation here, we're solving for momentum, so we want P is equal to mass times velocity. So let's go ahead and plug our numbers in. So P equals mass times velocity. And when I plug that into my calculator, I get 820. Remember that the unit for P here is kg, meters per second. We should always double check our sig figs. So 50 has how many sig figs? 1. 16.4 has how many sig figs? 3. Remember that you want to go with the lowest number of sig figs. So from 820, we get 800 kilogram meters per second. Let's take a look at example number 2, an 8 kilogram. What is kg the unit for? mass. So an 8-kilogram bowling ball is rolling in a straight line towards you. If its momentum is 16 kg/m/s, so they told us that was a momentum, how fast is it traveling? So if we're looking at fast, we are looking at speed. So I want the equation that is v equals something. So what would that be? V is equal to the momentum divided by mass. So let's go ahead and plug our numbers in. So V equals 16 divided by 8, and that gets us 2. And what's our unit for velocity? m/s. You should always check your sig fig. So 16 has how many? 2. 8 has how many? 1. So we only want to have 1 in our answer, which is what we have. Let's take a look at one last example. A beach ball is rolling in a straight line towards you at a speed of 0.5 m/s. So that is our V. Its momentum is 0.25 kg/m/s. What is the mass? So we want the equation here that is mass is equal to something, and that is equal to P divided by V. So let's go ahead and plug our numbers in. So m is equal to the momentum divided by the velocity. And I plug that in my calculator, and my calculator gives me 0.75, but we want to check our sig figs. So 0.25 has 2, 0.5 has 1. So I only want to have 1 sig fig in my answer, which means it's going to be rounded to 0.8. And what is the unit for mass? That is kg.